everyone to Dr. S class. Let's solve this problem together on dimension. The question is, a physical quantity Q is given by the expression Q equal to half rho V squared, where rho equal to density, V equal to velocity. The two questions we have to answer are these. Determine the dimension of Q, and B, what physical quantity does Q represent? If you look at this, it may sound a bit tricky, but it is very easy. All you have to do is keep to the rule. Remember to do dimension, all the known derived quantities, begin to change them mathematically in terms of the basic quantities. That's all we need to do. Now let's start. A. Q, which is the quantity given to us, we don't know what it is. We are told that the formula is half rho V squared. This rho is for density, V is for velocity. The first thing you will notice is there's a number, half. Anytime you are doing dimension, constants don't have any dimension. So just remove them. Any constant you see, especially numbers, just remove them from the expression. So to find the dimension of Q, we don't have to work with half. We just let it go. We take rho V squared. You remember, rho is density, and we are told that density is mass over volume. So that we don't confuse it with velocity. Then times velocity squared over 1. Now let's go over here. Q equal to mass is capital small m, which is a basic unit quantity. We don't have to touch it. Now we're going to change this volume V naught into its basic expression times velocity is distance over time, then it was squared. This is the same thing as mass basic quantity. We don't change it. We know that velocity, volume rather, is length times breadth times height. Each one of them here is a basic quantity like length, then times distance over time, each one of them squared. So distance, height, and breadth, we are going to change them to L, since L is the basic expression for length. So have M over L. Other than breadth, we write L. Other than height, we write L. Times, other than D, we write L squared, because that is for distance, and this is D squared. We are going to have M over L cubed times L squared over T squared. What do you notice? The same base, L, but the power of the numerator is 2, power of the denominator is 3. So we have M, L by indices, this is 2 minus 3, the base of this one. Then we have T raised to power minus 2. So we have here Q equal to M L raised to power minus 1 T raised to power minus 2. Dimension require that we use capital letter for mass, capital L for length, and capital T for time. And this is the dimension of Q. So now that we've gotten the dimension of Q, can I ask us, what physical quantity does Q represent? I can tell you, idea that the Q there actually represents something in physics, but let's find it out. D Q is equal to half rho remember we don't need constant or numbers when dealing with this. So we see that density is mass over volume times, let me use L for over time squared. Velocity is distance over time squared. I square this. Mass volume is L cube times length over time times length over time. L squared, L twice, I have them. T twice, I have them. Notice that distance over time is velocity. So I can actually write this as m over L cube times velocity over time times length over time. Though this is another velocity, but if I put it there, I'm going back to what was written. So I want to change it. Let me get something we're going to be familiar with. Okay. By indices, there's one L in the numerator, 3 L's in the denominator. So I'll cancel one here, cancel this. So I will have m over L squared times velocity over 1 times 1 over t. Now we can finish it here that q is equal to m over L squared times v over t. Now remember that v over t is acceleration, so we can say this is m a over L squared. This is m a over L squared means length times breadth, and that is area. So we see that q is equal to m a over capital A. From physics, we know that mass times acceleration is force divided by A. So for Q to be force over area means Q must be pressure, because we know that pressure is force over area, and that is the physical meaning of Q, pressure.